Hello there, and thanks for checking in. Today we're going to look at section 6.1, notes. So 6.1 is an introduction to circles. We're going to talk about a lot of new things with circles here, and we're going to start off right away with a couple vocabulary words, really 5 vocabulary words that we need to know for circles. So the first one here is a chord. A chord is a segment whose endpoints lie on the circle. And you can see right here, this is a chord. So the red one there, it starts at A and ends at B, it's called a chord because both of its endpoints are on the circle. Next one is a secant. A secant is a line that intersects a circle at 2 points. So this blue line here is called a secant. Line L is called a secant. And you can see that a secant actually contains a chord in it, but then goes on after both sides of the chord. A tangent is a line that intersects the circle one time. So this green line down here, line M, is called a tangent because no matter how far we extend this line, it's only going to touch the circle one time. So that's called a tangent. And then where it touches the circle at is called the point of tangency. So point C would be called our point of tangency. A couple other ones that you definitely need to know, but you probably already know. You can see my brown line here. This is called a radius. A radius is a segment that starts at the center and extends somewhere to the circle. And then the pink line here is called a diameter. A diameter is just a chord, but it's a special chord. It's a chord that goes through the center. So you can see both endpoints lie in the circle. It goes through the center. That's why it's called a diameter. Okay, the interior of a circle is everything that's inside the circle, and the exterior is everything that is outside of the circle. So lots of new vocab words that we need to know moving forward. So let's take a look at example 1. And it says to identify each line or segment that intersects circle L. So first we want to identify all the chords that we see here. Remember, a chord has to have both endpoints on the circle. So one chord would be segment KM. And there is one more, segment JM. A secant is a line that goes through the circle and hits it twice. So that only happens once. So that would be line JM. Notice how I use JM twice. The segment is a chord, but the line is a secant. Next one's a tangent. So a tangent only touches the circle one time. That would be right there. And that doesn't have 2 points. We can't name that with 2 points, but we can call that line M. And then H would be the point of tangency. It's not asking for that, but it's good to know. Diameter, there's only one diameter. Remember that a diameter is a chord. So it has to be one of our chords. It has to go through the center. So that would be segment KM. And finally a radius. A radius starts at the center and goes to the circle. So there's actually 3 of these here. There's 1, 2, and 3. So all of them must contain L, JL, KL, and ML would be our 3 radii. Okay, at this point I'd like you to pause the video and try this second example. Unpause the video when you've completed it. Here are your answers for example 2. Next, we're going to talk about pairs of circles. 2 circles are congruent if their radii are the same. So in this diagram here, if AC and BD are congruent, then the whole circles must be congruent to each other. Okay, and vice versa. If the circles are congruent to each other, then those 2 radii must also be congruent. Concentric circles are circles that have the same center. So somewhere you'd see this as like a bullseye or a target symbol. And then tangent circles are two circles that touch at exactly one point. So there's two different types of these. These are called internally tangent circles over here because they touch inside. These are called externally tangent circles because they touch at the outside. So number 3, find the length of the radius, identify the point of tangency, and write the equation of the tangent line at this point. So first of all, the radius of circle R. Here's the center. Just count in any direction how many units. 1, 2, 1, 2, 1, 2, 1, 2. You don't have to count all 4 times. Trust that they're all going to be the same. So the radius is 2. Then the radius of circle S. Again, you can count in any direction here. Let's just count this way and be 1.5. Next, the point of tangency is the point where they both intersect each other. That would be right there. That point is negative 2, 0. And then a tangent line. So you want to draw a line that goes through the point of tangency that touches both circles exactly once. That would be a horizontal line. In this case, it's not always horizontal, but in this case it is horizontal. See how it goes through the point of tangency and touches both circles one time? And the equation of that line, remember for horizontal lines, it's always y equals. So y equals 0. Okay, once again, I'd like you to pause the video and try example 4. When you've completed it, come back and unpause the video. Okay, there are your answers for example 4. Next theorem says if a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. So what does that mean here? If a line is tangent to the circle, it is perpendicular to the radius. So what's created when we have perpendicular lines? Right angles. So here we have our next example. In circle Q, the radius is 5. All right, so everywhere I see a radius, I'm going to put 5 down there. QT is a radius, so that's 5. And QR is a radius, so that's 5. Tangent segment TP is 12. The key there is that it's tangent segment. So we just learned that a tangent is perpendicular to a radius. So that means there's a right angle right there, which means we can use Pythagorean Theorem to figure out the third side. Because the next question says, what is the length of QP? So I'll let QP be x. And if we do the Pythagorean Theorem, we get 5 squared plus 12 squared equals x squared. Which is 25 plus 144, 169 equals x squared. And 13 is x. So segment QP is 13. Then it says, what is the length of RP? Well, I know QP is 13. I know QR is 5. So to get RP, we're simply going to do 13 minus 5. And RP must be 8. Example 2. RP is 2. The tangent segment is 4. Find GT. All right, so once again, it says tangent segment. So as soon as we see that, we know that there must be right angles where the radius and the tangent intersect. The problem here is that we don't know what GR is. But GR is a radius, and so is GT. And if they're both radii, they must be equal. So since GT is x, GR is x. Which means GP, this whole segment, is x plus 2. So now I can do Pythagorean Theorem. X squared plus 4 squared equals x plus 2 squared. I get x squared plus 16. Remember, x plus 2 squared means x plus 2 times x plus 2. So that's x squared plus 2x plus 2x plus 4. If I subtract x squared from both sides, I get 16 equals 4x plus 4. And finishing that algebra, finally I get x equals 3. But the question says to find GT. No problem, GT is x. So GT is 3. Then it says to find GP. Well, that's no problem either. GP is simply x plus 2. So GP is 3 plus 2. GP is 5. All right, the last type of problem we're going to see today. If two segments are tangent to a circle from the same external point, the segments are congruent. So we have two segments here that are tangent to circle P. And immediately tells us they're equal. It's a pretty basic theorem. So here we have HK and HG are tangent. They both come from H, so you immediately know they're equal. And that's it. That's your equation. 4 plus 2a equals 5a minus 32. Subtract 2a from both sides. Add 32 to both sides. And divide by 3. To get a is 12. Then it says to find HG. So HG is 4 plus 2 times 12, which is 28. So HG is 28, and it didn't ask for that, but we already know HK is also 28. All right, one last time. You can pause the video and try both 5 and 6, and when you finish both of them, come back and unpause the video. And there are your final answers for examples 5 and 6. That's it for section 6.1. Come back next time, we'll take a look at section 6.2.